for I in range of 3, and then I could print out a single hash mark to represent exactly that. I'm going to get the new line for free because that's the automatic default behavior for print. So if I run this, I get something that's a little underwhelming, but pretty close to the spirit of what I just did here on the screen. What if, though, I want to prompt the user for the height of this thing, just as we did in problem set 1 with the Mario problems? How can I make sure the user actually gives me a number I want? Well, let's go back to VS Code here. And just so that I don't have to implement all the try except stuff myself, let's go ahead and from CS50's library, import the getInt function that I've claimed exists. And then let's do this, while true. It turns out, in Python especially, it's actually pretty common to deliberately induce infinite loops, if only because Python does not have do-while loops. Recall that do-while loops in C were super useful because they guarantee that you do something while a condition is still true. And that allowed us to get user input at least once and maybe again and again and again and again. Python does not have a do-while. But you can implement the idea of it by just saying start an infinite loop that I'm going to plan to break out of when I am ready. And I could do something like this. N equals getInt, prompting the user for height here as a prompt. Then if n is what I want it to be, a value greater than 0, as in problem set 1, go ahead and break out of this loop. So even though I don't have a do while, I can certainly deliberately get myself into an infinite loop and break out of it when I'm logically ready to do so. And now here I can do for I in range of n, which is just going to iterate from 0 on up to that value, and then print out a hash mark as follows. Let me go ahead and run Python of Mario.py, type in a height of 3, and it still works. Type in a height of, say, 5, it too works by iterating 5 times instead of 3. As an aside, what are some modifications that might be germane here? Well, if I want to import the entirety of CS50's library, I can indeed, as I said earlier, just import the library itself. But notice what happens now. Python of Mario.py, enter a traceback, specifically a name error, getInt is not defined. This is because Python actually solves a problem that C does not. In C, we didn't actually encounter this because our programs haven't been too big. But in C, if you include this library and this one and this one and this one, you will get into trouble if 2 people out there have named a function the same thing. If they've typedef something the same thing. There's no notion of scope when it comes to importing libraries in C. You will get name collisions. And the solution is just don't do that. Don't use that library that conflicts with one you're using. The humans realized eventually this is probably not the best design. So they introduced the notion of namespacing, whereby you can scope certain symbols to specific files, in effect. And so there is a solution to this. If you import the entirety of CS50, that's fine. But you have to say that you want the function called getInt that's inside of the CS50 library. So if I do cs50.getInt and rerun this, now I no longer see that error, and I'm on my way again with the code. And this just allows me to keep all of my get_something functions scoped to the CS50 symbol, as opposed to importing them all into like the top level namespace, where they're just essentially global instead. All right, questions about this? The new ideas here really being now infinitely looping deliberately until you're ready to break out. Seeing none. All right, how about this? So we had these 4 like coins, question marks in the sky here, different in that they were horizontal instead of vertical. How might we implement this in code instead? Well, let's go back to Mario.py. Let's delete the vertical version we just did. And there's a bunch of ways I can do this, but let's do it in a way that lets us play around with some new features of Python as well. For I in range of, let's say, 4, though I could use a variable if I want, print out, quote unquote, question mark. And let's try this. Python of Mario.py, enter. This is, of course, buggy because they're coming out vertical instead of horizontal. So what's the fix there intuitively? What do I, yeah. Yeah, so add end equals quote unquote to turn off the new line by default. That's close now. So if I run Mario.py again, I get 4 horizontally, but I don't get the prompt on the new line. So I think I just need 1 extra print at the end, which does give me a default new line. So if I now run this one more time, there we go. Now we're back in business. So pretty straightforward, pretty much the same as in C, albeit with Python's more succinct syntax. But this is kind of cool. What you could alternatively do in Python, which we've not seen before, if you want to print something 4 times or some number of times, you can literally say, print out a question mark 4 times. So multiplication is now used in the way that plus kind of is for concatenation, but this does something again and again. Python of Mario.py, and that too now works. Doesn't really save us a huge amount of time, but it's kind of cool now that you can do these one-liners, so to speak, that achieve a lot more functionality as well. What about this final example we had from the world of Mario Underground, which was like a 3x3 grid? How could I do this in Python instead? Well, let's go back here and delete the version of code I had there. Just like in C, we can have nested loops. So I could do something like for I in range of 3, and then maybe for j in range of 3, using different variables deliberately here. Let me go ahead and print out a hash mark with no line ending until we're at the end of that row, at which point I do want a line ending, the new line character there. So if I run Python of Mario.py, I get a 3x3 grid, which roughly resembles what this thing here looks like. Now, you don't strictly need all of that because we can combine these ideas for better or for worse. If I go back to my code here, well, if I want to just print out 3 things, I could just do, let's see, print quote unquote hash mark times 3 and allow me to have a new line there. And if I run this version, which is a little tighter, I get the same exact thing too. So where is the line? Like, which way do you do it? Whatever is most comfortable to you. And in fact, when I said earlier that I was doing kind of flexing when I implemented dictionary.py using the fewest lines of code possible, that was just because I really wanted to distill it into the essence of the minimal number of lines of code. But I could absolutely have used some loops in dictionary.py. I could have used a little more verboseness. But as we're seeing here, it's not strictly necessary. Python has even more syntactic sugar, if you will, that lets you achieve more stuff more succinctly. All right. How about now some more on lists and dictionaries, just to dovetail with what we did last week. We'll touch on some final features too when it comes to command line arguments and using exit commands. And then we'll end with a couple of fun examples that kind of ties this all together. So in Python, we indeed have lists, which are like arrays, but they dynamically resize themselves. So they're effectively linked lists that you don't need to manage yourself. It turns out the documentation for those are at this URL here, but that's discoverable via docs.python.org itself. In particular, there's functions you can use on lists like len, L-E-N for short, which gives you the length of a list. In C, it was up to you to keep track of the length of an array. In Python, like in Java, like in JavaScript, if you're familiar, you can just ask the list how long it is at any moment in time. So that's going to make our lives a little easier as well. In particular, here's some documentation for that length function. And let me take it out for a spin by recreating some of our prior examples in code. Let me go back to VS Code here. And let me go ahead and create a program called scores.py, which just like our example in week 2, sort of iterates over quiz scores or homework scores or however you want to think about scores. In Python, I'm going to give myself just a list of 3 scores, same as in week 2. So scores equals square brackets 72, 73, 33. So this is different from C. In C, if you were initializing an array with values like these, you would actually use curly braces and a semicolon. And the data type in Python, you use square brackets, no data type, no semicolon. OK, as before. Now let's compute like the average of my score. So average equals, and here's another function that actually exists in Python's documentation. You can actually call a function called sum, pass in most anything that you can iterate over, like a list, passing in scores, and then divide by how many of those things there are, like len, passing in scores there. And now if I want to print out the average, I can print out, for instance, a format string that says average colon, and then plugs in that value there. I can try running this, Python of scores.py, and there's my average, as we've seen before weeks ago, 59.33333, with a little bit of imprecision thrown in for good measure, as before. But what's nice is that, notice, sum just comes with the language. Length just comes with the language. You don't need some annoying for loop or a while loop just to figure out the average of these values by doing all of that math yourself. So that seems to be nice at a glance. What else can we do with these here scores? Well, let me propose that we could get them one at a time from the user instead of hard coding them. So let me do this. Let me go ahead and from CS50's library import getInt, just so I don't throw any of those exceptions by typing in cat or dog or anything not an integer. Let's give myself an empty list by just using 2 square brackets like that. And now let's go ahead and put things in that list as follows. For I in range of 3, if I want to prompt the user still for 3 scores for the sake of discussion, let's prompt the user for a score, putting it in a variable called score, setting it equal to the getInt function, prompting them for their first score. But then let's put that score in the list. In C, this was a pain in the neck. In C, this was like what you had to do in problem set 5 and build the darn linked list yourself by iterating over the chains and appending it to the end or to the beginning or something like that. In Python, if you want to append a value to an existing list, you do whatever that list is called, scores in this case. You use a method that comes with it called append, and you append that score. And voila, like Python takes care of it for you, putting it at the end of the list. Now, outside of that loop, let me calculate the average just as before, the sum of those scores divided by the length of those scores. Then let's go ahead and print out an f string that says average colon, and then interpolates the value of that variable. Now, if I didn't screw up, let's try this again. Python of scores.py, 72, 73, 33, which are now, per that for loop, being added to the list. And then the logic is exactly the same. So way easier than it would have been in C to navigate or manage all of that stuff for me. There's another way to see this, syntactic sugar, if you will. If you don't like this syntax, whereby you are adding to the scores variable a new score by appending it using the built-in append function or method that comes with any list in Python, you can also do this. You can set scores equal to the existing scores list plus another mini list containing just that score. Or I can condense this a little further and say plus equals score. So it turns out plus is overloaded in Python in the sense that it's not a concatenation per se like for strings, but it's append. You can append more and more things to a list by concatenating two lists together in this way. So again, achieves the exact same thing, but maybe you prefer this syntax, if only because it's a little more concise. But in short, like lists are wonderfully useful in this way. Questions then on this here feature as well. We're essentially just like solving past problems more easily is the theme, hopefully. OK, how about one other problem when we implemented like a phone book back in week 3? Let me go ahead and do this. In VS Code, let me clear my terminal and close out scores.py. And let me go ahead and create a new program called phonebook.py. And in this, let's write a program that just iterates over some names looking for one that I want. So maybe I have an array, a list called names, set it equal to 3 of us, as in week 3. So Yulia and David and maybe John Harvard, like this, all 3 strings. Then let's go ahead and prompt the user for a specific name using Python's input function or our getString method function, prompting them for a specific name. And now let's do this old school with a for loop. For each name in names, and I'm just keeping it short, n for names, n for each name, if the name I'm looking for equals the current name that I'm iterating over, then print out found, as we did weeks ago, and then break out of this loop because I'm done. And let's see what happens here. So Python of phonebook.py, let's search for my own name, David, enter, and David's name is found. So that's kind of handy. Let's do this once more. Search for John. John is now found. Let's search for, say, another name, but let me mistype it maybe, like Yulia in all caps. I'm not handling any of the capitalization here, so I don't think she will be found. And indeed, we see no mention of found. Now, this is a feature of Python that's kind of handy too. And it's a little weird because in C and in Scratch, the only time you could use else was with conditionals. But we've seen in Python, you can also use else with exceptions, those special errors that can be triggered. You can even use else's in Python with for loops by saying else print not found. And what happens in Python is if Python realizes you never actually break out of this loop yourself, it will then print out this only if you've not broken out. The logic being that, OK, you clearly didn't find who you were looking for, so else let's just say as much. So if I now run this again, typing in Yulia's name, all capitalized, so miscapitalized here, enter, I do now see that she's not found. So it's just a nice little trick because it's so common to iterate through things, fail to find a value, and then you just want to say some default, you want to execute some default line of code as well. But turns out, let's tighten this up too. Python does not need you to do all of this work by iterating over every name in the list, checking if each name is in there. Rather, we can tighten this up even more. Let me get rid of this entire for loop and just say this. If the name you're looking for is in the list of names, then print found, else, in this conditional, print not found. In other words, I can literally just ask Python, you search over the darn list for me, and if it's in there, wherever it is, return true in that Boolean expression, or in that if conditional, the Boolean expression in effect, so I can print out found or not found. So this too will just work. Let me go ahead and run this again at the bottom. Python at phonebook.py, search for myself, David, and I am indeed found. But I don't need to implement the searching for it left to right. It's still using linear search under the hood, but someone else has now written that code for me built into the language itself. All right. So what more do we get? So it turns out that in the world of programming, like maybe one of the most useful data structures is indeed a hash table, which gave us the